Breaking news from Starbase, Texas. Starship Flight 6 is officially set for November 18th, marking a historic milestone. The fastest turnaround time ever for a super heavy-lift rocket. This incredible achievement even surpasses the legendary Saturn V's record from the Apollo era. But that's just the beginning. Flight 6 isn't just another launch. It's packed with groundbreaking tests that could revolutionize spaceflight as we know it. We're talking about the first-ever Raptor engine relight demonstration in orbit, a completely redesigned thermal protection system, and a spectacular daylight re-entry over the Indian Ocean that promises to be absolutely breathtaking. The most exciting part? SpaceX is pushing the envelope even further by attempting another precision catch of the Super Heavy booster, a feat that was considered impossible just a month ago. This time, they've refined the trajectory and made crucial improvements to protect those outer engines during re-entry. Welcome to Elon Musk 24 Hours, your front row seat for what could be the most ambitious Starship flight yet. Let's dive right in. The anticipation at Starbase is electric as we witness SpaceX's meticulous preparation for Flight 6. Fresh footage from Flight 5 reveals something extraordinary. A stunning view of hot staging that looks straight out of science fiction. The brilliant blue glow of Raptor engines illuminates the night sky as ship and booster execute their cosmic dance. For the first time, we can see the precise choreography of the engines during separation, with center engines pivoting outward to minimize force on the hot staging ring before gracefully returning to center. But that's not all the footage revealed. We got our first underwater view of Starship's splashdown, a surreal scene of this massive spacecraft gracefully submerging, with water cascading over its flaps like a metallic waterfall. The camera continues rolling even as it plunges several meters beneath the surface, proving SpaceX has mastered yet another crucial capability. Now let's break down what makes Flight 6 a potential game-changer. SpaceX has refined their timeline with fascinating precision. Launch is set for 4 p.m. Central Time, an afternoon launch that strategically positions the spacecraft for a daylight re-entry. This isn't just for show, it enables unprecedented visual data collection during one of the most critical phases. The pre-launch sequence reveals SpaceX's relentless drive for efficiency. They've actually increased propellant loading time, seemingly counterintuitive, but there's brilliant engineering at work here. While longer fueling means more boil-off of the cryogenic propellants, this temporary adjustment allows SpaceX to expand their infrastructure to Pad B. When fully operational, this expanded capability will enable the rapid launch cadence needed for ambitious future missions. The loading sequence itself has been meticulously choreographed. The booster begins taking on propellant a minute earlier than previous flights, with ship fueling carefully timed to ensure optimal propellant temperatures. Every second counts in this delicate dance of super-chilled liquids and precision timing. At T-30 seconds, ground control gives the final go for flight. The flame deflector activates, creating a spectacular water curtain around the pad. Not just for show, but a critical component in protecting the launch infrastructure from the immense energy about to be unleashed. Then comes the moment of truth. Ignition. The roar of 33 Raptor engines signals the start of something unprecedented. The flight profile shows fascinating tweaks from Flight 5. MECO, main engine cutoff, happens 1 second earlier, a subtle but significant change possibly linked to reduced ship weight from removed heat shield tiles. Each removed tile represents a careful balance between weight savings and thermal protection, with SpaceX pushing the boundaries of what's possible. Hot staging follows just 7 seconds later, showing SpaceX's growing confidence in this radical maneuver. This technique, once considered too risky for large rockets, has become a signature capability of the Starship system. The precision required is astounding, igniting engines on the upper stage while still attached to the booster, with clearances measured in mere centimeters. Then comes the booster's dramatic return. SpaceX has completely reimagined the descent trajectory, delaying when Booster 13 hits transonic speeds. This isn't just flight path optimization. It's a direct response to the outer engine damage observed during Flight 5's re-entry. By spending 8 additional seconds in controlled descent, the booster can better manage its thermal load through the most critical phase of atmospheric re-entry. The landing attempt introduces multiple decision points where both computer and human controllers must make split-second choices. After Flight 5's near-abort scenario, which almost resulted in an intentional ground impact, SpaceX has revamped their commit criteria. Each parameter must be precisely within limits, from descent rate to lateral drift, from engine performance to structural loads. This isn't just about landing a rocket, it's about landing it with absolute certainty of success. The catch mechanism itself represents a marvel of engineering. The chopsticks must track and match the motion of a massive descending booster, accounting for wind conditions and last-minute adjustments. The margin for error is measured in inches, despite dealing with a vehicle standing taller than most skyscrapers. But while the booster works to stick its landing, Ship 31 continues higher, carrying unprecedented tests with it. After reaching near orbital trajectory at T+827, it enters its coast phase. Unlike previous flights, there's no break in the action. At T+3746, SpaceX attempts something never before seen on a Starship flight, a Raptor engine relight in zero gravity. This test is far more complex than it might appear. In the absence of gravity, propellants don't simply flow to the bottom of their tanks. SpaceX must use a sophisticated system of ullage thrusters and propellant management devices to ensure the Raptors receive a steady flow of fuel and oxidizer, free from potentially destructive bubbles or voids. The implications of this test are enormous. Without reliable engine relights in orbit, Starship can't execute the complex orbital maneuvers required for satellite deployment, lunar missions, or eventual Mars journeys. It's also crucial for safe deorbiting. Without it, Starship would risk becoming an uncontrolled re-entry hazard. Ship 31's thermal protection system represents another leap forward. The new secondary thermal protection system could revolutionize how Starship handles the extreme heat of atmospheric re-entry. While the primary heat shield tiles are highly effective, their brittleness has been a concern. This backup system provides redundancy while potentially offering new capabilities for future missions. The strategic removal of certain heat shield tiles isn't just about weight savings. These modifications are testing the groundwork for future catch-enabling hardware, a crucial step toward full reusability. Each removed tile represents careful thermal analysis and risk assessment, with SpaceX pushing the boundaries of what's possible while maintaining robust safety margins. The higher angle of attack during re-entry will stress test the ship's aerodynamic control surfaces like never before. This aggressive profile generates valuable data about control authority and heating rates, critical information for future landing attempts. Combined with the afternoon launch timing, this creates perfect conditions for unprecedented visual and thermal data during the daylight re-entry over the Indian Ocean. The technical refinements continue throughout the mission timeline. Re-entry begins at T+47 minutes and 13 seconds, with the ship reaching transonic speeds at T+1 hour, 2 minutes, and 6 seconds, 22 seconds later than previous flights due to the modified angle of attack. This extended high-altitude deceleration phase allows for more precise control and data collection. The landing maneuver begins around T+1 hour 5 minutes, with the dramatic flap reconfiguration and engine-powered flip maneuver leading to what we hope will be the third successful splashdown. Each successful water landing brings SpaceX closer to attempting a catch of the ship itself, the holy grail of full system reusability. Behind the scenes, preparation continues at a breakneck pace. The hot staging ring for Booster 13 has rolled into the megabay for stacking, representing countless hours of refinement based on data from previous flights. Each weld, each connection, each sensor has been optimized based on real-world experience. Ship 31 sports a whimsical touch, a banana for scale decal, referencing an old aerospace engineering joke. But don't let the humor fool you. This vehicle represents the cutting edge of rocket technology. The completed heat shield installation and road closure notices signal that final preparations are nearly complete. Most significantly, this flight bridges the gap to Block 2. SpaceX has confirmed that Flight 7 will feature a Block 2 ship, likely Ship 33, already being prepared with Raptor 2.5 engines. These engines, while not the final Raptor 3 design, incorporate crucial improvements in reliability and performance. One vacuum engine even has an interesting history, previously starring in a Tesla commercial and infamously claiming a drone as its first casualty during filming. The rapid pace of development means some hardware won't fly. Ship 32 may never leave the ground, but this ruthless focus on forward progress is exactly what sets SpaceX apart. They're willing to scrap completed hardware if better designs are ready, always pushing toward their ultimate goal of making humanity multi-planetary. Looking ahead, Flight 6 appears to be much more than just another test. It's a carefully choreographed demonstration of multiple critical capabilities, from engine relights to thermal protection systems, from precise landings to infrastructure expansion. Each element has been refined based on previous flights, building toward a fully reusable super heavy lift launch system that could revolutionize access to space. The implications extend far beyond just technical achievements. This rapid iteration, this willingness to test and fail and improve, represents a fundamental shift in how humanity approaches space exploration. Each flight brings us closer to a future where space travel is as routine as air travel, where Mars is a destination rather than a dream. As Flight 6 approaches, we're witnessing more than just another launch. We're seeing the future of space exploration unfold. From the groundbreaking engine relight tests in orbit to the daring daylight re-entry, every aspect of this mission pushes the boundaries of what's possible in spaceflight. SpaceX continues to redefine the impossible, turning science fiction into reality with each launch. The fastest turnaround time in super heavy lift rocket history isn't just a record, it's a statement about the future of space travel. When we look back at this moment, Flight 6 may well be remembered as the turning point where routine space access became truly achievable. The combination of booster catch attempts, orbital engine relights, and advanced thermal protection systems demonstrates SpaceX's holistic approach to achieving full reusability. Each success brings us one step closer to regular Mars missions and establishing humanity as a multi-planetary species. As we anticipate this historic launch on November 18th, stay connected with Elon Musk 24 hours for exclusive updates and expert analysis. Hit subscribe now to join our growing community of space enthusiasts and be the first to know about future developments. Drop a comment below with your predictions for Flight 6. Will we see another successful booster catch? How will the new thermal protection system perform? Don't forget to give this video a thumbs up if you're excited about the future of space exploration. Share it with fellow space enthusiasts who need to know about this groundbreaking mission. Together, we're witnessing history in the making. See you at launch day. This is Elon Musk 24 Hours, your premier source for all things SpaceX and beyond.